Hello friends, today we are going to read chapter 1 of the book Certificate Physical and Human Geography written by Leong. So let us start. The title of chapter 1 is The Earth and the Universe. Exploring the Universe. On a fine bright night, when you look up at the sky, it seems to be studded with stars. Little do you realize that each of the stars is far bigger than the earth on which we live. Some of the larger ones have been estimated to be many millions of times the size of the earth. These stars are not scattered regularly in space, they occur in clusters, better described as galaxies or nebulas. Each galaxy may contain as many as 100 million stars. It is believed that the Earth's own galaxy, the Milky Way, alone contains as many as 100,000 million stars. The stars appear small to us even through a telescope because they are so far. The light from the nearest star traveling at the speed of light, that is 186,000 miles per second, takes something like 4 years to reach us. A ray of light from the sun takes about 8 minutes to reach the earth. Light takes only a second to reach us from the moon. The solar system. The solar system comprises the sun and its 9 planets, which are believed to have been developed from the condensation of gases and other lesser bodies. All the planets revolve around the sun in elliptical orbits. Like the earth, they shine only by the reflected light of the sun. The sun has a surface temperature of 6,000 degrees Celsius and increases to 20 million degrees Celsius in the interior. All over its surface are fiery gases that leap up in the whirls of glowing flames like a volcano in eruption. In size, the sun is almost unimaginable. It is about 300,000 times as big as the earth. Amongst the 9 planets, Mercury is the smallest and closest to the sun. Only 36 million miles away, it thus completes its orbit in a much shorter space of time than does Earth. A year in Mercury is only 88 days. Venus, twice the distance away from the sun, is the next closest planet. It is often considered as Earth's twin because of their close proximity in size, mass, and density. But no other planet is in any way comparable to Earth, which has life and all the living things we see around us. Like many other planets, the Earth has a natural satellite, the Moon, 283,900 miles away, that revolves eastward around the Earth once in every 27 days. The fourth planet from the Sun is Mars, which has dark patches on its surface and is believed by most professional astronomers to be the next planet after Earth to have the possibility of some plant life. Much attention has been focused on Mars to explore the possibilities of extending man's influence onto it. Next comes Jupiter, the largest planet in the solar system. Its surface is made up of many gases like hydrogen, helium, and methane. It is distinguished from other planets by its circular light and dark bands and the 12 satellites that circle around it. As it is more than 485 million miles from the sun, its surface is very cold, probably about minus 200 degrees Fahrenheit or minus 130 degrees Celsius. Here you can see the figure of the solar system. Another unique planet is Saturn, which has 3 rings and 9 satellites around it. In size, it is the second largest after Jupiter. It is so far from the Sun that it takes 29.5 years to complete its orbit. The 7th planet, Uranus, was not known to astronomers until the late 18th century when it was first seen as a faint bluish-green disk through a very powerful telescope. It is another giant planet, 50 times larger than Earth and 15 times as heavy. Unlike other planets, Uranus orbits around the Sun in a clockwise direction from east to west with 5 satellites revolving around it. The 2 outermost planets in the solar system, Neptune and Pluto, are just visible with telescopes. Their discoveries were the result of mathematical calculations on the irregular gravitational effects on neighboring planetary bodies. Friends, I would like to tell you that Pluto is a dwarf planet. Pluto is not a planet. Neptune closely resembles Uranus, except that it has only 2 known satellites and is probably much older. Pluto is smaller than Earth. As the orbits of the planets are not circular but elliptical, The distance of Pluto from the Sun during perihelion, that is when it is closest to the Sun, is 2766 million miles, and at aphelion, that is when it is farthest from the Sun, is 4566 million miles. A year in Pluto is no less than 247 years on Earth. Due to their very recent discovery and their extreme remoteness from the Earth, very little is so far known about these last two planets. The shape of the Earth. In the olden days, sailors feared to venture far into the distant ocean because they thought the Earth was as flat as a table. They thought that when they reached the edge of the Earth, they would slip down and perish in the bottomless ocean. This is, of course, not true. From years of accumulated knowledge, experience, and observations in different parts of the world, we know that the Earth is round. Its spherical shape is an established fact, proved and accepted by all. There has been so much research done on Earth science that its various dimensions have been accurately found. It has an equatorial circumference of 24897 miles and its polar circumference is less by 83 miles. Its equatorial diameter is 7926 miles and its polar diameter is shorter by 26 miles. This simply shows that the Earth is not a perfect sphere. It is a little flattened at both ends like an orange. It can in fact be called a geoid, Earth-shaped. The spherical shape of the Earth is also masked by the intervening highlands and oceans on its surface. Now we will talk about the evidence of the Earth's sphericity. There are many ways to prove that the Earth is spherical. The following are some of them. Circumnavigation of the Earth. The first voyage around the world by Ferdinand Magellan and his crew from 1519 to 1522 proved beyond doubt that Earth is spherical. No traveler going round the world by land or sea has ever encountered an abrupt edge over which he would fall. Modern air routes and ocean navigation are based on the assumption that the Earth is round. You can see here the picture of circumnavigation of the Earth. You can see the second picture also. The circular horizon. The distant horizon viewed from the deck of a ship at sea or from a cliff on land is always and everywhere circular in shape. This circular horizon widens with increasing altitude and could only be seen on a spherical body. This is illustrated in figure 3. We will show you. Ship's visibility. When a ship appears over the distant horizon, the top of the mast is seen first before the hull. In the same way, when it leaves harbor, its disappearance over the curved surface is equally gradual. If the Earth were flat, the entire ship would be seen or obscured all at once. This is apparent from figure 4. You can see here the figure 3. Another one. This is the figure 4. This is another one. Now, sunrise and sunset. The sun rises and sets at different times in different places. As the Earth rotates from west to east, places in the east see the sun earlier than those in the west. If the Earth were flat, the whole world would have sunrise and sunset at the same time, but we know this is not so. Now, the lunar eclipse. The shadow cast by the Earth on the moon during the lunar eclipse is always circular. It takes the outline of an arc of a circle. Only a sphere can cast such a circular shadow. Now, planetary bodies are spherical. All observations from telescopes reveal that the planetary bodies, the sun, moon, satellites, and stars have circular outlines from whichever angle you see them. They are strictly spheres. Earth, by analogy, cannot be the only exception. Seventh is driving poles on level ground on a curved earth. Engineers, when driving poles of equal length at regular intervals on the ground, have found that they do not keep a perfect horizontal level. The center pole normally projects slightly above the poles at either end because of the curvature of the earth. As illustrated in figure 6, surveyors and field engineers therefore have to make certain corrections for this inevitable curvature, that is 8 inches to the mile. See the figure 6. Eighth is aerial photographs, pictures taken from high altitudes by rockets and satellites show clearly the curved edge of the Earth. This is perhaps the most convincing and the most up-to-date proof of the Earth's sphericity. This is the picture. Now we will talk about the Earth's movement. Man is always conscious of the apparent movement of the sun, and little realizes that the earth on which he stands is constantly in motion. When the sun disappears, he says that the sun sets, and when it emerges, he says that the sun rises. He is not the least aware that the sun in fact does not rise or set. It is we who rise and we who set. The earth moves in space in two distinct ways. It rotates on its own axis from west to east once in every 24 hours, causing day and night. It also revolves around the sun in an orbit once in every 365, 1 by 4 days, causing the seasons and the year. Day and night. When the earth rotates on its own axis, only one portion of the earth's surface comes into the rays of the sun and experiences daylight. Here is the picture. The other portion, which is away from the sun's rays, will be in darkness. As the earth rotates from west to east, every part of the earth's surface will be brought under the sun at some time or other. A part of the earth's surface that emerges from darkness into the sun's rays experiences sunrise. Later, when it is gradually obscured from the sun's beams, it experiences sunset. The sun is in fact stationary and it is the earth which rotates. The illusion is exactly the same as when we travel in a fast-moving train. The trees and houses around us appear to move and we feel that the train is stationary. Figure 7 explains the Earth's rotation and the causes of day and night. We have already seen the figure 7. The Earth's revolution. When the Earth revolves around the Sun, it spins on an elliptical orbit at a speed of 18.5 miles per second, or 66,600 meters per hour. One complete revolution takes 365, 1 by 4 days or a year. As it is not possible to show a quarter of a day in the calendar, a normal year is taken to be 365 days. Need an extra day is added every 4 years as a leap year. Varying lengths of day and night. The axis of the Earth is inclined to the plane of the ecliptic. Ecliptic is the plane in which the Earth orbits around the Sun at an angle of 66.5 degrees, giving rise to different seasons and varying lengths of day and night. If the axis were perpendicular to this plane, all parts of the globe would have equal days and nights at all times of the year. But we know this is not so. In the northern hemisphere, in winter, in December, as we go northwards, the hours of darkness steadily increase. At the Arctic Circle, 66.5 degrees north, the sun never rises and there is darkness for the whole day. In midwinter on 22nd December. Beyond the Arctic Circle, the number of days with a complete darkness increases until we reach the North Pole 90 degrees north, when half the year will have darkness. In the summer, June, conditions are exactly reversed. Daylight increases as we go polewards. At the Arctic Circle, the sun never sets at midsummer 21st June, and there is a complete 24-hour period of continuous daylight. In summer, the region north of the Arctic Circle is popularly referred to as land of the midnight sun. At the North Pole, there will be 6 months of continuous daylight. Figure 8.a illustrates the revolution of the Earth and its inclination to the plane of the ecliptic, which causes the variation in the length of day and night at different times of the year. You can see here the figure. In the southern hemisphere, the same process takes place, except that the conditions are reversed. When it is summer in the northern hemisphere, the southern continents will experience winter. Midsummer at the North Pole will be midwinter at the South Pole. The second one is the altitude of the midday sun. In the course of a year, the Earth's revolution round the sun with its axis inclined at 66.5 degree to the plane of the ecliptic changes the apparent altitude of the midday sun. The sun is vertically overhead at the equator on 2 days each year. These are usually 21 March and 23 September, though the date changes because a year is not exactly 365 days. These 2 days are termed equinoxes, meaning equal nights, because on these 2 days all parts of the world have equal days and equal nights. After the March equinox, the sun appears to move north and is vertically overhead at the Tropic of Cancer 23.5 degree north on about 21st June. This is known as the June or summer solstice, when the northern hemisphere will have its longest day and the shortest night. By about 22 December, the sun will be overhead at the Tropic of Capricorn 23.5 degree south. This is the winter solstice, when the southern hemisphere will have its longest day and the shortest night. The tropics thus mark the limits of the overhead sun, for beyond these, the sun is never overhead at any time of the year. Such regions are marked by distinct seasonal changes: spring, summer, autumn, and winter. Beyond the Arctic Circle and the Antarctic Circle, where darkness lasts for 6 months and daylight is continuous for the remaining half of the year, it is always cold. For even during the short summer, the sun is never high in the sky within the tropics, as the midday sun varies very little from its vertical position at noon daily. The four seasons are almost indistinguishable. Days or nights are almost equal all the year round. Third one is seasonal changes and their effects on temperature. Summer is usually associated with much heat and brightness, and winter with cold and darkness. Why should this be so? In summer, the sun is higher in the sky than in winter. When the sun is overhead, its rays fall almost vertically on the earth, concentrating its heat on a small area. Temperature therefore rises and summers are always warm. In winter, the oblique rays of the sun come through the atmosphere less directly and have much of their heat absorbed by atmospheric impurities and water vapor. The sun's rays fall faintly and spread over a greater area, and there is thus little heat and temperatures remain low. In addition, days are longer than nights in summer and more heat is received over the longer daylight duration. Nights are shorter and less heat is lost. There is a net gain in total heat received and temperature rises in summer. Shorter days and longer nights in winter account for the reverse effects. Now we are going to talk about dawn and twilight. The brief period between sunrise and full daylight is called dawn, and that between sunset and complete darkness is termed twilight. This is caused by the fact that during the periods of dawn and twilight, the earth receives diffused or refracted light from the sun while it is still below the horizon. Since the sun rises and sets in a vertical path at the equator, the period during which refracted light is received is short. But in temperature latitudes, the sun rises and sets in an oblique path and the period of refracted light is longer. It is much longer still at the poles, so that the winter darkness is really only twilight most of the time. Now we are going to talk about the mathematical location of places on the globe. The Earth's surface is so vast that unless a mathematical method can be used, it is impossible to locate any place on it. For this reason, imaginary lines have been drawn on the globe. One set of running east and west parallel to the equator are called lines of latitude. The other set runs north and south, passing through the poles, and are called lines of longitude. The intersection of latitude and longitude pinpoints any place on the Earth's surface. For example, Delhi is 28 degree 37 minute north and 77 degree 10 minute east. London is 51 degree 30 minute north and 0 degree 5 minute west. And Sydney is 33 degree 55 minute south and 151 degree 12 minute east. We shall examine more closely how latitude and longitude are determined and the role they play in mathematical geography. Now we are going to talk about latitude. Latitude is the angular distance of a point on the Earth's surface, measured in degrees from the center of the Earth as shown in figure 10. It is parallel to a line, the equator, which lies midway between the poles. These lines are therefore called parallels of latitude, and on a globe are actually circles becoming smaller pole warts. The equator represents 0 degree and the north and south poles are 90 degree north and 90 degree south. Between these points, lines of latitude are drawn at intervals of 1 degree. For precise location on a map, each degree is subdivided into 60 minutes and each minute into 60 seconds. The most important lines of latitude are the equator, the Tropic of Cancer, the Tropic of Capricorn, the Arctic Circle, and the Antarctic Circle. As the Earth is slightly flattened at the poles, the linear distance of a degree of latitude at the pole is a little longer than at the equator. For example, at the equator, 0 degree, it is 68.704 miles. At 45 degree, it is 69.054 miles, and at the poles, it is 69.407 miles. The average is taken as 69 miles. This is a useful figure and can be used for calculating distances to any place. Bombay is 18.55 degree north. It is therefore 18.55 into 69 or 1280 miles from the equator. With the aid of your atlas, find the approximate distance of the following places from the equator, that is Singapore, Calcutta, Paris, New York, Buenos Aires, and Auckland. This is a figure. Now we are going to talk about longitude. Longitude is an angular distance measured in degrees along the equator east or west of the prime or first meridian, as indicated in figure 11. On the globe, longitude is shown as a series of semicircles that run from pole to pole passing through the equator. Such lines are also called meridians. Unlike the equator, which is centrally placed between the poles, any meridian could have been taken to begin the numbering of longitude. It was finally decided in 1884 by international agreement that to choose as the zero meridian the one which passes through the Royal Astronomical Observatory at Greenwich near London. This is the prime meridian 0 degree from which all other meridians radiate eastwards and westwards up to 180 degree. Since the Earth is spherical and has a circumference calculated at 25,000 miles in linear distance, each of the 360 degrees of longitude is 25,000 divided by 360 or 69.1 miles. As the parallels of latitude become shorter polewards, so the meridians of longitude which converge at the poles enclose a narrower space. The degree of longitude therefore decreases in length. It is longest at the equator where it measures 69.172 miles. At 25 degree it is 62.73 miles. At 45 degree it is 49 miles. At 75 degree it is 18 miles, and at the poles 0 miles. There is so much difference in the length of degrees of longitude outside the tropics that they are not used for calculating distances as in the case of latitude. But they have one very important function. They determine local time in relation to GMT or Greenwich Mean Time, which is sometimes referred to as world time. Now we are going to discuss longitude and time. Local time. Since the Earth makes one complete revolution of 360 degree in one day or 24 hours, it passes through 15 degree in 1 hour or 1 degree in 4 minutes. The Earth rotates from west to east, so every 15 degree we go eastwards, local time is advanced by 1 hour. Conversely, if we go westwards, local time is retarded by 1 hour. We may thus conclude that places east of Greenwich see the sun earlier and gain time, whereas places west of Greenwich see the sun later and lose time. If we know GMT to find local time, we merely have to add or subtract the difference in the number of hours from the given longitude as illustrated below. As simple memory add for this will be east gain add and west lose subtract. You could coin your own rhymes for the abbreviations. Hence, when it is noon in London, the local time for Madras will be 5 hours 20 minutes ahead of London. But the local time for New York will be 4 hours 56 minutes behind London. We can put it in another way. When Londoners are having lunch, Indians will have dinner, and New Yorkers will have breakfast. This is difficult to believe, but it is true. The rotation of the earth around the sun means that at any point in time, different places will experience a different time of day. There are many ways of determining the longitude of a place. The simplest way is to compare the local time with GMT by listening to BBC radio. This is a figure. For example, the captain of a ship in the midst of the ocean wants to find out in which longitude his ship lies. If CMT is 8 am and it is noon in the local region, it means that he is 4 hours ahead of Greenwich and must be east of Greenwich. His longitude is 4 into 15 degree or 60 degree east. Now we are going to discuss standard time and time zones. If each town were to keep the time of its own meridian, there would be much difference in local time between one town and the other. 10 am in Georgetown, Penang would be 10.10 in Kota Baru, a difference of 2.5 degrees in longitude. In larger countries such as Canada, USA, China, India, and USSR, the confusion arising from the differences alone would drive the people mad. Travelers going from one end of the country to the other would have to keep changing their watches if they wanted to keep their appointments. This is impracticable and very inconvenient. To avoid all these difficulties, a system of a standard time is observed by all countries. Most countries adopt their standard time from the central meridian of their countries. The Indian government has accepted the meridian of 82.5 degrees east for the standard time, which is 5 hours 30 minutes ahead of Greenwich Mean Time. The whole world has in fact been divided into 24 standard time zones, each of which differs from the next by 15 degrees in longitude or 1 hour in time. Most countries adhere to this division, but due to the peculiar shapes and locations of some countries, reasonable deviations from the standard time zones cannot be avoided. Larger countries like USA, Canada, and USSR, which have a great east-west stretch, have to adopt several time zones for practical purposes. USSR, the largest country, which extends through almost 165 degrees of longitude, is divided into 11 time zones. When it is 10 p.m. on Monday night in Leningrad, it will be almost 7 a.m. the following Tuesday morning in Vladivostok. Travelers along the Trans-Siberian Railway have to adjust their watches almost a dozen times before they reach their destination. Both Canada and USA have 5 time zones: the Atlantic, Eastern, Central, Mountain, and Pacific time zones. The difference between the local time of the Atlantic and Pacific coast is nearly 5 hours. This is the figure 13, the 5 time zones of the North America. Now we are going to read the international dateline. A traveler going eastwards gains time from Greenwich until he reaches the meridian 180 degrees east, when he will be 12 hours ahead of GMT. Similarly, in going westwards, he loses 12 hours when he reaches 180 degrees west. There is thus a total difference of 24 hours or a whole day between the two sides of the 180 degree meridian. This is the international dateline, where the date changes by exactly one day when it is crossed. A traveler crossing the dateline from east to west loses a day because of the loss in time he has made, and while crossing the dateline from west to east, he gains a day because of the gain in time he encountered. Thus, when it is midnight Friday on the Asiatic side, by crossing the line eastwards, he gains a day. It will be midnight Thursday on the American side. That is, he experiences the same calendar date twice. When Magellan's ship eventually arrived home in Spain in 1522 after circumnavigating the world from the Atlantic Ocean to the Pacific Ocean and westwards across the international dateline, the crew knew nothing about adding a day for the one they had missed. They thought they had arrived on the 5th of September. They were shocked to be told that the date was 6th September. A modern aircraft leaving Wellington at 5 p.m. on Friday reaches Hawaii 4,100 miles away at 2 p.m. the same Friday. The same aircraft on its return journey from Hawaii leaves at 6 p.m. on Friday but arrives at Wellington in 11 a.m. on Sunday. Can you explain this? The international dateline in the mid-Pacific curves from the normal 180 degree meridian at the Bering Strait. Fiji, Tonga, and other islands to prevent confusion of day and date in some of the island groups that are cut through by the meridian. Some of them keep Asiatic or New Zealand Standard Time, others follow the American date and time. The international date line is shown in figure 14. Now these are the questions and exercises for the chapter 1. So we have completed reading the chapter 1. So friends, in the next video we will read the next chapter, chapter 2. So subscribe the channel, press the bell icon, stay tuned, study well. Thank you.